Hello, and welcome to today's problem, 75 sort colors. You're given an array nums with n objects colored red, white, and blue, and you want to sort them in place so that the objects of the same color are adjacent along with the colors in the red, white, and blue. We want to use the integers 0, 1, and 2 to represent the color red, white, and blue, and you want to solve it without using the library sort function. Another thing we also need to look out for is that we should do it with a one-pass algorithm using only constant space. Okay, now taking a look at the examples here, we're given this array as an input and we have this as an output. And from first glance, it looks like the output is just a sorted version of the original input over here. Now, one way we could implement this would be just by having a sorting algorithm. So something like quicksort or like merge sort. I think the fastest sorting time complexity for let's say something like a merge sort would be n log n. So it would solve this problem, but let's try to think of some more ways which would be more efficient. So we know that the properties of the array is that there's 0, 1, and 2, and you basically know that everything at the start is going to be 0, right? We want everything in the middle to be 1, and we want everything at the end to be 2. So maybe we could have a left and a right pointer which kind of partitions this array so that everything to the left of one of the pointers would be 0, and then everything to the right of one of the pointers would be 2, and everything in between the left and the right pointer would be 1. So let's say we have that over here right now. We have left, and then we have right, and then we need some sort of way to iterate through it. So we'll have an I pointer over here. Now, okay, let's think about this. Okay, so let's say you start off with this I pointer over here. You check to see what the current element is at. It's 2, right? And with 2, we know that 2 has to be at the very end. So what we can do is we can swap that 2 variable with the element at the very ends and have 0 over here. So and then after we do that operation, we can move the right pointer to the left because we know that this is 2 now, so we can just decrement it by 1 and have the next element that's going to be swapped be put into this position as well. So we could do that again, and then we can go ahead and check to see whether or not the current element over here at the current index is 2. Well, it's not because it's 0. It's the element that's just been swapped. So then what we can do is move forward once, check again. So for this element, it's 0. Where do we know? Where does 0 have to be in this case? Well, we know that it has to be at the very left of the array, so we can swap it with the current element at the left of the array, and that happens to be the left one. So 0 and 0 swapped again. It's just 0 and 0. So after we do that, we swap it. So we can move this pointer forward 1 since we know that this for sure is 0. And then from here, we can go ahead and check the current element again. We'll move the right pointer forward, or the I pointer forward, and then we'll check this again. Oh, it's a 2. We can swap this. We can make this 1, and then we can check this again to see whether or not it's a 1 or a 2. It's a 1, so we just increment this forward. It's a 1, it's incremented forward. We keep incrementing it forward until we hit the very end over here. So as you can see, we've reached our final solution, and we've done so in only one pass, having the left pointer or right pointer and having no place, basically having nowhere that we're storing the values in. So it's a constant extra space over here. A way to do it with extra space would be by utilizing bucket sort and just moving the values of the array to different buckets and then printing out that amount afterward, but that would be less efficient because of the constant extra space as opposed to the solution. So we'll go ahead and begin implementing this out right now. We'll have the left pointer here, and we have the right pointer over here, and we have that set to 0, and then we have length of nums minus 1, starting at the very end. We have the current I pointer, which is set to 0, and while I is less than or equal to the right, what we want to do is we want to check to see if nums at the current index is equal to 0, then we're going to want to swap it with the left. So we can do nums I, nums left equals nums left nums I. So we can go ahead and swap that. After that, we're going to want to increment the left pointer by 1. And then at the very end, we want to increment the right pointer by 1. The I pointer by 1 regardless. Now we have another situation. If nums at the I is equal to 2, we want to put that at the very right of the array, at the right pointer. So we're going to do nums right, nums I and nums right, and we're going to want that to be equal to nums r nums I. So we'll swap that, and we'll move the right pointer, well, decrement the right pointer by 1. And okay, so for this particular situation, we know that if we move the left pointer by 1 and we swap these, we know for sure that everything to the left of the left pointer is going to be 0, right? Let's say like we have a situation for the right pointer where we have to, basically we have like some sort of like element here, right? And then we have like a 2 over here, right? So let's imagine the scenario. If we hit this, let's say that this is 0 actually. So imagine this, it's like this, right? We see that 2 is at the current index and at the right pointer it's 0. So we swap this and then we make this 2 over here. So this is valid, right? We decrement the pointer by 1 for the right side, etc, etc. But at this current pointer, if we just increment it regardless, then it'll skip over this, and there could be a situation that occurs where 0 is in between the left and the right pointer, which doesn't make sense because we want everything between the left and the right pointer to be equal to 1. So in order to negate this and have it check again, just in case to see if it's 0, what we need to do is we need to decrement the right pointer by, or like the index pointer by 1 in order to basically negate this always incrementing. So if we go ahead and run this now, it should be good. Let's actually do one more check to see that everything is as according to plan. We'll run this through in our head. Left foot pointer and right pointer is 0, length of nums minus 1, I is equal to 0. While I is less than or equal to the right, you want to check to see whether or not it's equal to 0. We swap it with the left one and we increment the left pointer by 1. If it's equal to 2, then you swap it again, except with this time with the right pointer. You decrement the right pointer by 1, you decrement the I pointer, and this increments it, which makes it not move at all, and it'll go ahead and check again at the very end. So if you go ahead and run this now. Okay, nice. Fully accepted, and there you have it. Thanks for watching.